Hello students, I hope that you are good, well and fine. Today we will be continuing our discussion on the topic of inverse trigonometric functions, class 12th, chapter 2nd. Okay, so far we have discussed the basic concepts, the sine function graph and the theory, cos function graph and the theory, the cos inverse function and the sine inverse function. We also saw the cosec inverse function theory and its graph, and we also saw the same thing for the sec inverse. In this today's lecture we will be covering tan inverse function and its graph, cot inverse function and its graph, and we will see some points regarding to all of these points, and or we can say that important points we will be covering in this note section over here, and then we will be practicing some examples. Okay, so let me recall you these previous things so as quickly as I can. So sin x domain is minus infinity to plus infinity. That means the whole real numbers. The range is minus 1 to 1, closed interval minus 1 to 1. For cos x, domain is minus infinity to plus infinity. Range is the minus 1 to 1 closed interval. For tangent, the domain is all real number except pi by 2 plus an integer multiple of pi. Okay, and the range will be what? All real numbers. Same we can say that the cotangent domain is x not equals to k pi, or say that x cannot be multiple of pi. Okay, the domain is x cannot be multiple of pi, and the range will be the all real numbers. And for secant, x cannot be equals to pi by 2 plus k pi, or we can say the odd multiples of what? Pi by 2. Okay, and the the range will be what? Minus infinity to minus 1 closed interval, and closed interval at 1 comma till infinity. Okay, and for cosecant, domain cannot be equals to the multiple of pi. Take any real number except multiple of pi. Okay, now the range will be what? Minus infinity to minus 1. Minus 1 is inclusive, and 1 to infinity, where 1 is also inclusive over here. I hope that this is you can all remember. Okay, so this is what we already discussed. Okay, let me skip this. Now we saw for sine inverse we need 1 1 and on 2, and in this interval sine function is 1 1 as well as on 2. So then we can talk about its inverse function, which is sine inverse, and sine inverse is from where to where? Sine inverse from minus 1 to minus pi by 2 to pi by 2, where we say that this is what? The principal value branch. Okay, let's move to next. We saw this interesting property hold that sine of sine inverse x must be equals to x only when only if this the input of sine inverse x must be minus 1 to 1. Okay, and from this we can also say that sine inverse of sine x is equals to x only when the input of sine inverse function is in between this. So this means minus 1 less than equals to sine x less than equals to 1, and we know this happens when pi by 2 minus pi by 2 to x belongs to minus pi by 2 to pi by 2. Okay, okay, let's move to next as the graph for the sine inverse function. Sine function is this in this interval minus pi by 2 to pi by 2, and its inverse graph will be what? The inverse graph will be like this. Okay, so inverse graph will be like this. Okay, let's move to next, the cos inverse function. In cos inverse function, to get the inverse function for cos, we need to find that where in what interval the cos function is 1 1 and on 2. So in interval 0 to pi, this is 1 1 as well as on 2. Now, so from this what I can say that cos inverse function now defined from minus 1 to 1 closed interval minus 1 to 1 to the codomain will be what? Closed interval 0 to pi. Okay, so and this is what we called as the principal value branch. Okay, and the graph for it will be in cos x 0 to pi. We take only this part of cos function. Okay, cos function, and the inverse for this is this. Okay, let's move to next as cosecant function. Now cosec, the cosec function is 1 1 when you are talking about in this interval, this minus pi by 2 to pi by 2, except 0 will not be included over here. Okay, and the domain will be this. For cosec, the function is from minus pi by 2 to pi by 2 except 0, and to this what will be your codomain or the range will be r except minus 1 to 1. Okay, and cosec inverse we can define respectively. So this is the domain in this case, and codomain, or you can say the range, because this is also 1 1. Okay, let's move to next. Let's see the graph. So as we took this and this part only, the graph for it will be what? The graph for cosec inverse x you will be getting by just mirroring with respect to y is equals to x. Then after mirroring, what you will get, this will be changed like this. So at 1, this will be at 1, somewhere 1, as you can see 1. So this and this line, so at minus 1 you will be get this. So minus 1 somewhere here. So as you can see minus 1, this starts like this. Okay, and this is what? 0. So as you can see, this is here. Okay, asymptote over here, asymptote over here. Let's move to next, sec inverse. For sec inverse, the principal value branch is what? This closed interval 0 to pi except pi by 2. Okay, for sec. Okay, and this will be what? The domain in case of sec inverse function, and this will be what? Our range as well as the codomain set. Okay, let's move to next. So this is our what? The 1 1 and the onto part of the sec x function. If you try to find out the inverse, just take a mirror with respect to mirror image with respect to what? Y is equals to x line. You will get what? This will be where? Here, somewhere here. As you can see at pi you will get this, and it is going near pi by 2. As you can see here, this point is pi by 2. So this is getting closer to pi by 2. Now this, as you can see, this starts with 1. So this starts something like this. So from 1 like this, and going closer to, as you can see, it is becoming or getting closer to pi by 2. So here is your pi by 2 asymptote, and now as you can see, your sec inverse x is getting closer as you keep going on, the x value gets to plus infinity, the sec inverse x getting closer to what? Pi by 2. Okay. Now for tan inverse function, if you recall what, that tan function, tan x is what, if you recall, is sine by cos. If you recall the graph for it will be like this. Yes. Okay. This point is what, or this line is what? Pi by 2, and this line is what? Minus pi by 2. Okay. And in this interval, we know that my tan x is 1 1 as well as 1 2. So my principal branch will be what? Minus pi by 2 to pi by 2 closed interval, sorry, open interval. Okay, so this means what? So tan x is now defined from minus pi by 2 to pi by 2 to where the whole set R, as you can see. Okay, now what? Now the respectively we can define the tan inverse function from where to where? R2 minus pi by 2 to pi by 2 open interval, as you can see over here. Yes. So the principal value branch will be what? This minus pi by 2 to pi by 2. Okay. Now what will be its inverse graph look like? Okay, so quite easy. How? If you try to mimic around where the y is equals to x. Okay, so y is equals to x. If you try to find out the mirror image of the graph, how it will be looking, it will look like something this. So if you image mark, so let me use different, so this. Okay, so okay, like this and this. So the inverse will look like this and this. As you can see, the domain is a whole R here, and the range will be what? Minus pi by 2 to pi by 2. Okay, so the neat and clean diagram for it will be like this. So this is my what? This is my tan x. If I will be taking this to this interval, open interval, then my inverse, I can find my inverse, and that inverse will look like this, as you can see. Yes. Yes. Okay. So whenever you got like this, the increasing left to right, but increasing, you will get what? Up to down. Up, sorry, to down to up, down to up. Okay, in this way, as you can see. Okay, I hope that you understood every graph. Okay, now let's move to this graph for cot inverse. For cot inverse, we know what we know. Let's understood by the graph. So cot x graph looks like this. Okay, cot x graph looks like this. Okay, if you take 0 to pi, then your function will be what? 1 1 and on 2 as. Okay, from this what you can say, that if cot is defined from this interval to R, this is 1 1 as well as on 2, then you can talk about the cot inverse function, and the cot inverse function will look like R to what? 0 to pi. And because in this interval only, this is 1 1 and on 2, this means this is what? Principal value branch. Okay, and the inverse function, how will you be getting the inverse graph? Just do nothing, take the mirror image of the graph with respect to y is equals to x. What you will get? You will get your graph like this. Okay, like this. Okay, I hope that it is now very clear to you. Okay, as you can see here, pi by 2, here it is also pi by 2. It is in between 0 to pi. As you can see, here is 0, here is pi. Okay, I hope that it is clear to you. Okay, let's move to next. Now, if you try to observe every theory or the all inverse function, you will get what? In short, you will be getting thus for sine inverse function, the domain is closed interval -1 to 1 and the range will be what? Minus pi by 2 to pi by 2. Okay. For cos inverse, the domain is -1 to 1 closed interval and closed interval 0 to pi is range. Okay. Now, for cosec inverse, the domain is all real number except open interval -1 to 1 and the range will be what? Closed interval minus pi by 2 to pi by 2 except 0. We exclude 0. Okay. And for sec x, sec inverse, the domain remains the same as the cosec inverse function, but if you talk about the range is closed interval 0 to pi, but we exclude pi by 2 point over there. Now, in tan inverse function, the domain is the whole real number set R and the range will be minus pi by 2 to pi by 2, open interval minus pi by 2 to pi by 2, and for cot inverse, the domain remains the same, the whole set of real numbers, and the range will be what? 0 to pi, open interval. Okay, I hope that everything you understood clearly. Let's move to next. Now, notes. The important notes are given over here. So, first note says, when we are saying the inverse function, sine inverse, don't confuse with this thing. Okay, any inverse function we studied, please do not confuse them with this notation, because this is not equals to this thing sine x whole inverse, and this means what? 1 upon sine x. So this is not equal. Okay, this thing means the inverse of sine function, but this means sine x whole inverse. This means just the reciprocal of sine x. Okay, so don't confuse with it. Okay, I hope that it is clear to you. As you can see that sine inverse x, or let use x is equals to pi by 4, not pi by 4, say 1 by root 2. So sine inverse 1 by root 2 is what? We know pi by 4. Okay, so x is what? X is what? 1 by this, and we know what? We know sine of 1 by root 2 will be what? Will not be equals to what? Pi by 4. Or let me take a quite simple example. So for example, if x is 0, then sine inverse 0 will be what? 0. Sine 0 will be what? 0. Okay, but you know this is equals to 0 and this will be equals to what? 1 by 0, and this is not defined properly. Okay, so and we know from this we can say that sine inverse x is not in generally not equals to sine inverse whole sine x whole inverse. Okay. Now, whenever no branch of an inverse trigonometric function is mentioned, okay, we mean the principal value branch of that function. Okay, if suppose you are not given with any branch, okay, then by default please take the specific or according to the given function its principal value branch. Okay. The third point says the value of an inverse trigonometric function which lies in the range of principal branch is called the what? Principal value of that inverse trigonometric function. Okay. I hope that it is clear to you. So the point 3, what it says, the value of an inverse trigonometric function. So this means if you try to find out this value, what you will be getting as minus as pi by 4. And from this, what we can say that which lies in the range of principal branch. Okay. So the value of an inverse trigonometric function. So the value of an inverse trigonometric function in this case is pi by 4, which lies in the range of a principal branch. As you can see, the principal branch for sine inverse is what? Is if you recall is minus pi by 2 to pi by 2 closed interval. Yes, as you can see, this pi by 4 belongs to this interval. Okay, then the principal value. So in the range of principal branch is called the principal value. So we say this as principal value. Okay, so we say what? So this is what? The principal value. Okay, I hope that you now understood what do we mean by third point. Okay, now let's move to next. Let's do some examples. So find the principal value. We need to find the principal value. That means find the x belongs to the principal value branch. And we know in sine inverse, for sine inverse function, the principal branch is minus pi by 2 to pi by 2. This means we need to find out such x which is 1 by root 2. Yes, which is 1 by root 2, and we know what it is. It is pi by 4. So your answer will be what? Pi by 4. Your answer will be what? Pi by 4. Okay. Now let's do next. So whenever such type of question asked to you, just first of all do what you will do is try to write this equals to what? Say x. Okay, then what? Just what you will do, take this. I am just abusing some notations. Don't I am just giving you a way to calculate your answer quickly without facing any difficulty. Okay, you just follow these, you will get your answer. Okay, now what you will do, you will say that it is cot x will be equals to this. Okay, now what we know, first of all, we know we are talking about principal value. So this x must belongs to the what? Principal value branch. Yes, if you recall, what is our principal value branch for cot x? If you recall the graph for cot x, so let's see the graph for cot x. The graph looks like this, 0 to pi. So 0 to pi, so this must be open interval 0 to pi. The principal value branch will be what? Open interval 0 to pi. So our x must belongs to this interval. Okay, so and now what can you think that we know that cot x is now what? Some negative real number. Yes, if you recall, at what say quadrant cot x must lie? If you recall that in first quadrant every trigonometric function is positive. Okay, in second quadrant sine and what? Cosec are positive. Okay, sine and cosec are positive, and in fourth tan and cot are positive, and in in third and in fourth cos and sec are positive. Okay, now what? Now from this what you can say that either this x belongs to this quadrant or this quadrant. Yes, this quadrant or this quadrant. And what we know, first of all, what we know is this, that either it lies in the second quadrant or in the fourth quadrant. Okay, in the second quadrant and in the fourth quadrant. First of all, what you can see, can you think that what value for x, what value for x, it is equals to what? Is equals to 1 by root 3. So can you think what value of x, it is equals to 1 by root 3? As you can write, what you know that it is what? 1 by 10x. Yes, so this means what? 10x must be what? Root 3. And when will this happen? This happens when we have root 3 by 2 and 1 by 2. And this happens when sine x is what? Sine x is pi by 3. Yes, sine x is pi by 3 and cos x is also pi by 3. Yes, if you recall the values, that sine 60, which is sine 60 degree, which is what? Pi by 3. Yes, is equals to what? Root 3 by 2. And for cos 60, it is equals to 1 by 2. Or you can say cos pi by 3. Okay, so from this, what you can say, x is equals to, x is what? Pi by 3. But we are talking about minus 1 by root 3. We are talking about minus 1 by root 3. Okay. Cot pi by 3 is equals to 1 by root 3. Okay. We know what we know. Either your x belongs to this quadrant or in this quadrant. Okay. If you can see here, from here, what you can say is x is belonging to where? Your first quadrant. Yes, your first quadrant, because pi by 3 is less than pi by 2. Yes. So how you are going to make this happen? So it is quite easy. Whenever you see this, what you will do is just take pi. Okay, if you are if you want that your function will be at here, then you will do what? This is what? Whole pi. Yes, this is what? Pi. And if you minus this number, where you will be at? Somewhere here, still somewhere in the second quadrant. Yes. So now if you apply, because we know what we know, any trig function minus pi minus say theta will be what? Either it will be in say a plus, or either it will be in minus. It's depend on what function we are taking, but it remains the whatever function we are using here, any trig function is equals to plus minus the same trigonometric function. Okay. So this means, what this means, say, so this remains as cot, as if you solve this, pi minus pi by 3, pi minus pi by 3 is what? We are in which quadrant? In second quadrant. So this means this will remains as, so cot is equals to what? We are in what quadrant? Second quadrant. And we know cot in the second quadrant will be what? Cot in the second quadrant is negative, and we know, and if you solve this, what you will get is 2 pi by 3. You will get it as 2 pi by 3. So cot pi minus pi by 3 is equals to what? Not this. So this, and we know this is minus pi by 3. Okay, minus pi by 3, the same trigonometric function with angle theta. This is what do I mean. Okay, so from this what we can say is that minus cot pi by 3 is equals to cot pi minus pi by 3, which is equals to this. Now we have arrived to our solution that the x will be what, 2 pi by 3, as now as you can see that 2 pi by 3 is less than pi, as you can easily verify that. Yes, so this belongs to the open interval 0 to pi. So the value or the principal value will be what, 2 pi by 3. As you can see, what we did, we first of all took cot inverse minus 1 by root 3 is equals to y, and then we just take the cot to the left hand side, sorry, the right hand side, then we write like this, which is further can be rewritten as what? From here, what can you rewrite it as? 1 by root 3 is equals to what? Cos minus cos y. Okay, then we know this. From this, what we can say, cot pi by 3 is equals to what? Minus cot y. Okay, now what? Now we know what we know. I can rewrite it as again cot y is equals to minus cot pi by 3. Okay, now what? Now from this what I can say is that minus cot pi by 3 is equals to cot pi minus pi by 3. And from this what I can say that is cot 2 pi by 3, and from this I can say that y is equals to 2 pi by 3. Okay, I hope that it is now clear to you. I think that this way is quite easy if you compare the previous steps. Okay, so that's it for now. Thank you. We will be meeting next time. Thank you again.